All right, so going over the answer key here. On number one, when you have a point and you want to know if it's a solution to a system, you need to plug it in to both equations. Let me fix the light a little bit here. So you want to plug it into both equations. So 3 minus 9 times 2 equals -3, and it has to work in both of them. 18 equals -3, so -3 equals -3. So it works in the first one. 3 minus 3 times 2 equals 6, so 12 minus 6. Okay, so it works in both of them. That's what I mean by showing work. And then don't forget to answer it. If it works in both of them, you're either going to say yes. Now, if it didn't work in one or both, then you would say no. But still show both of them. Like, let's say it didn't work in the first one. Still test the second one. Show both of them, but if it doesn't work in either one, it would be a no. Number 2, solve the system using substitution. This is where some of you are having a little difficulty. When you want to solve for substitution, look for the variable between the two equations. Look for the variable that's the easiest to solve for. I wouldn't try to solve for this x, because then I'm going to have to divide by 2 and end up with fractions. I wouldn't solve for either of these, because these are going to result in fractions. This one is already y. It doesn't have a coefficient in the front. That's the easiest one to solve for. So I'm going to rearrange this equation by throwing the 2x on the right side. And it gives me y equals -2x plus 7. This, which is y, is going to get plugged into the y spot on the other equation. 2 times -2x plus 7 equals -7. And now I have an equation that's all in x's. So that I can solve. Watch your signs here when you distribute. That's going to be plus 4x minus 14 equals -7. So 7x minus 14. Throw the -14 on the other side. 7x equals 14 minus 7. So 7x equals 7, which means x is going to equal 1. And then I can take this and plug it in to either equation and solve for y. But this one, the one I rearranged, is already set up for y. I'm going to use that and plug in my x. So we're going to get y equals -2 plus 7, which means y equals 5. And then you want to write it as a point. 1, 5. That would be the point of intersection if we were to graph these. Okay, number 3 is also substitution. Looking at both these equations, this is the variable I want to solve for. It's already just an x. It doesn't have a number in the front. If you were to solve for any of these other 3, you're going to end up with fractions. You could still do that, but it's harder. So I'm rearranging this one, solving for the x. And then this, which is x, is going to get plugged into the x spot in the other equation. Plus 2y equals 13. Notice that it doesn't matter if you're solving for an x, like in number 3, or you're solving for a y, like in number 2. Whatever is easiest to solve for is what you want to do. All right, then finishing it up, 14y plus 77, y equals 13, y plus 77. Toss the 77 over, so it's minus 16y equals, that'll give me a -64 dividing by 16. So y equals -4. And then plugging that in, x equals 2 2 times negative 4. Negative 8 plus 11. So x is going to equal 3. And that point is 3, negative 4. Okay. 4. Also substitution, looking for the easiest variable. This is the one I want to solve for. So y equals 3x plus 1. I'm moving the 3x to the other side, changing the sign. That is going to get plugged into the y spot on the other equation. Minus 4, 3x plus 1 equals negative 3. X minus 12x, minus 4 equals negative 3. Okay, right off the bat, those are going to cancel out, and I get negative 4 equals negative 3, which is nonsense. So this must be a no solution, meaning these lines are parallel. Or you could use, all right, the no solution sign, either one. Okay, number 5, elimination this time. So I am going to, normally they're stacked up, but I'm going to multiply this second equation by 4, because then this x will be 4x, this will be negative 4x, and when I add them, the x's will drop out. So multiply by 4, and this is going to give me negative 4x plus 20y. Right, when you multiply by 4, every term gets multiplied by 4. And then equals negative 52. Then I can add these two, so the x's drop out. That's going to give me 35y. 17 plus negative 52 will be negative 35. Divide by 35, and y equals negative 1. And then I can plug that y into either equation. I'll just use this one here. Negative x plus 5 times negative 1, negative 13. So negative x minus 5 equals negative 13. Move the negative 5 over, becomes positive 5. Negative x is negative 8. And remember, when you have a negative variable, what you're doing is multiplying both sides by a negative 1, basically. That's going to just change the signs. So x is positive 8, and y is negative 1. Now, one thing I'm not doing, just for time, is I'm not going back and plugging in to check each solution. You want to do that on the tests, and any test or quizzes, you always want to plug that into both equations and make sure it works. All right, next page. Let's see, that's that guy. Where's my next one? Okay, number 6. Also solving by elimination. Looks like these are both y's, so if I multiply either equation by negative 1, then my y's are going to drop out. So I'll just multiply this one by negative 1, and I'll get 3x minus y equals positive 5. Now I'm going to add these. My y's are going to cancel, and that's going to equal a negative 11. And then divide by 11. So x equals negative 1. Plugging back in, negative 3 times negative 1 plus equals negative 5. Okay, toss the 3 over. Y equals negative 8. Negative 1. Negative 8. Okay. Let's see. Let me do one more. Number 7, I could either multiply this equation by a -5, which would make a -20 at y and 20y, so the y's will drop out. Or I can multiply the x by -5. That's interesting. They're both going to drop out. All right, so I'm going to multiply this one by a -5. And so I get -5x minus 20y equals -15. That drops out, that drops out, that drops out, and I get 0 equals 0, which looks weird, but that's a true statement. So all the variables dropped out, you get a true statement. That means infinite solutions. In other words, these lines, these two lines are really the same line. And that is my answer.